In this video, we are going to talk about quadratic solutions. So to bring this back to what you guys learned in the first week of this chapter is that I gave you a parabola. A parabola is a U-shaped graph, which is graphed when you plug in a quadratic equation, which means there's an x squared in the equation. So what we said is that these ordered pairs right here live on the x-axis. Those are called x-intercepts. They're also called solutions, roots, and zeros. So all of these words mean the same thing. It means this ordered pair right here and this ordered pair right here. So this unit, we are now shifting over to only focusing on these ordered pairs right here. So these are quadratic solutions, okay? There's three different things that could happen when you graph a parabola onto a graph. So in this first example here, when this one is graphed, it has two solutions. The solutions of this graph is that it's at -3, 0. That's one solution. And the other solution touches the x-axis at 2, 0. That can also be written as x equals -3 and 2. So sometimes solutions are written as ordered pairs, because that's the ordered pair where it touches the x-axis. And other times it's just written as the number, the x's, the solutions are 3 and -3 and +2. Okay, so you can write it either way, and that would be the correct answer there. So in this next example, this one touches the x-axis one time. So there's only one solution. If I looked at this x-axis, how many times does my blue function touch the x-axis? Just one time. So this thing here has one solution. The one solution of this is the ordered pair. It went to the right 1, 0, which is the same as saying x equals 1. So that's the second type, is it would touch it one time to have one solution. The third option is when you graph a graph, here's my x-axis, and it never touches the x-axis. So this one has no solutions. It has no solutions because it doesn't touch the x-axis. So you wouldn't have to put anything there. There are no solutions. There are 0 solutions because it never touches, my blue parabola never touches that x-axis. When you get to Algebra 2, you'll learn some fancy math for what happens in this case. But for what we're doing in Algebra 1, these first two are what you will see most often, is a graph will touch it 2 times to have 2 solutions, or the graph will touch the x-axis one time to have one solution. Okay, so how can we figure out where these solutions are? Let's first talk about a table. So a table of values means that you take this equation, and when you plug in the number -3 in for x, you would end up with some value. So what we're going to do is we're going to take this and we're going to plug it into Desmos, so that way we can fill out the table. So I'm going to type in y equals x squared minus x minus 6. Y equals x squared minus x minus 6. Okay, so from the graph, I see where the solutions are, but I want to be able to fill out a table. So the way that we get a table from Desmos is we click this little spiky circle, and then you click this little table. The first number that's on my worksheet that it wants is the number -3. So I'm going to type in -3. Whoopsie daisies, not like that. -3. The next number it wants is -2. Then it wants -1. Then it wants 0. Then it wants 1, 2, and 3. Okay, so these here are the numbers that are on this table. So what this is telling me is that in this graph, I'm going to get rid of these guys down here. I don't want, you guys already have this. Goodbye. It's going the wrong way. Hold on, sorry guys. I'm just getting rid of these because they don't have to be here. So I want 1, 2, and 3. Okay, there we go. Sorry, I'm picky. So in this one here, the ordered pair -3, 6. That's this ordered pair right here, -3, 6. It lives on this line. So what I'm going to write is -3, 6 is a number from y equals x squared minus x minus 6. I plugged it into Desmos. I opened the table. When x is negative 3, the y value of this equation is a 6. When x is a negative 2, the y value of the equation is a 0. When x is negative 1, the y value is negative 4. When the x value is 0, the y value is negative 6. When the x value is 1, the y value is negative 6. When the x value is 2, the y value is negative 4. Come on. And then finally, when the x is 3 on this graph, when the x number is 3, my y is 0. Okay, so now, solutions are also called zeros. What this means is that from a table, my solution or my answer is when there is a 0 in the back. So when I look at what I have here, there's a 0 in the back of this one and a 0 in the back of this one. Not this one. I don't want him. That 0 is not in the back. So zeros or solutions are when there's a 0 in the back. So that means that my answer is negative 2 comma 0 and 3 comma 0. On a test, or if you're getting lazy, you could just write that my x's are negative 2 and positive 3. So those are my two solutions. So on this graph, if I were to look at this graph, I would have an x-intercept. It would touch the x-axis at negative 2, and it would touch it at positive 3. Here's the graph. Let's see if that's right. Does it touch it at negative 2 and positive 3? It sure does. I knew that from the table. Here's a 0, so that's negative 2. Here's another 0, that's positive 3. Okay? So the correct answer is the number, the x value, that has a 0 in the back. So when you're ready, you're going to do the same thing with these next ones here. You're going to type this into Desmos, y equals x squared plus 3x plus 2. You're going to click the little spiky circle. Some people call it a cog. Some call it a settings symbol. Some call it a gear. That symbol has a lot of names. And then you click the little table. So to build a table, type in when x is negative 3, you're going to tell me what the y value is. When x is negative 2, tell me what the y value is. Okay? So when you're ready, you're going to do that. Then you're going to figure out which are the zeros. Where are the zeros? What number has a 0 in the back? When does it touch the x-axis? That's the solution. That's the x equals. Sometimes it only touches it one time, which is fine. Sometimes it touches it 2 times. Okay? When you're ready, you're going to go to the third one and then the fourth one as well. Not too bad. So that's how we figure out what the solution from a table. Solutions from a table. That's how you would do it. All right, now we're moving on. How to figure out where the solutions are from an equation without using technology. Okay, so in the future, you're going to have to do all of this without a calculator. You'll have to do it on the SAT, on different tests without a calculator. So that's why it's important to first see it. I like to use technology so you guys can see what's happening. And then I like to give you the skill so you can do it on your own. So in this next one here, what we have is an equation. On the left side, here's my x's, that's the equation. And then if you notice, it's set equal to 0. The reason why it's set equal to 0 is because we need the zeros of the equation. Ooh, sorry guys. So I'm going to figure out where on the graph the zeros, the solutions, the x-intercepts, where are they? So step 1, your equation has to be equal to 0. So in number 1, there's a 0 in the back, so we're good to go. So what we do, this is called the zero product property. What that means is we're going to take the first piece and set this equal to 0. And we're going to take the next piece and set it equal to 0. So we are going to solve to see where this quadratic equation is. So in this first example, to solve for x, this takes us way back to the first week of school. If this is a plus 5 and we need to get x by itself, I'm going to subtract 5 from both sides. That leaves me with a number x equals negative 5. In the second one, to get x by itself, I need to add 4 and add 4. That leaves me with x equals positive 4. So now I'm going to graph this. X equals negative 5 is the ordered pair right here. X equals positive 4 is right here. We know that these always make a U shape, so this would be the graph of this parabola. So your answer for number 1 is x equals negative 5 and x equals positive 4. We take both pieces and we set them equal to 0. When you're ready, go ahead and try the same thing with number 2. Okay. All right, so once you're ready with number 2, you should have x equals 7 and x equals negative 1. Not too bad. Let's move to number 3. So number 3 is the exact same idea. Don't let it confuse you. I'm going to set the first piece equal to 0, and then I'm going to set the second piece equal to 0. The first one's easy. I know how to solve this. To get x by itself, I move the 2 by subtracting 2. Easy. To get this next one, x needs to be by itself. What we have to do is solve for x. The way that we solve for x in a two-step equation is you start by moving the constant. That's the number. If that was a minus 4, I need to plus, if that was a minus 1, I need to plus 1. I'm going to plus 1 here. That leaves me with 3x equals positive 1. To get x by itself, I'm going to divide both sides by 3. And that leaves me with x equals 1 over 3. It's a fraction, but that's okay. 1/3 is just a number between 0 and 1. So to graph this, negative 2 on the x-axis is right here. 1/3 is just between 0 and 1, approximately right there. I connect my dots, and that would be the quadratic equation that goes with this here. My solutions, my x's, I was able to solve. I got this and this. So now I want you to try number 4. Same idea. It's just a two-step equation. 6x plus 4 equals 0. Negative 4x plus 2 equals 0. How do you solve them for x? Two-step equation to get x by itself. Move the constant and then divide. So when you're ready, I want you to do the same thing with number 5. On number 5, it's a little tricky. This x right here gets a 0, and then this piece right here gets a 0. X equals 0 is already solved. X is already by itself, so that's one solution. Oops. And this one here, to get x by itself, I subtract 1 from both sides. That leaves me with 2x equals negative 1. To get x by itself, I divide by 2. So that's the number x equals negative 1/2. To graph this, x equals 0 is the ordered pair right in the middle. X equals negative 1/2 is just right next door. Teeny, teeny, tiny little x-intercepts there. That one's kind of ugly. But those are your answers. X equals 0 and x equals negative 1/2. On number 6, what we've learned about this type is anytime you see a square, it means you write it twice. So I just took 5x minus 1, and I write it twice. So when you're ready, go ahead and set both of those equal to 0 and see what you get. All right, last piece of today. So when you saw this, your brain should have thought, this looks familiar. I've taken 2 parentheses and done some work with them before. So in Unit 8, the last unit, you guys factored. When you factored, you took something that looked like this, and you turned it into 2 parentheses. So that's what we have to do here. The reason why we factored in Unit 8 was so that we could solve quadratic equations in Unit 9. So in the last chapter, we took a trinomial and we turned it into its 2 factors. So that's what we're going to do on number 7. So the way that we factor, we draw an x. If there's no number in front, that's a 1. Label A, B, C. The number A times the number C is 1 times 9, which is a 9. B stands for bottom. Let me put this here to help you. A times C is the top, B is the bottom. The number that goes on the bottom is a 6. So what I need to figure out is what multiplies to make 9, but adds to make 6. And the correct answer is 3 times 3 makes 9, where 3 plus 3 equals 6. So the next step of factoring is you take the first term and you write it down. If it comes from the x puzzle, it needs an x. That's called splitting the middle. Instead of writing that 6x, we're writing its 2 factors. So now I have its 4 pieces. The first term came down. I split the middle into 2 pieces. The last term came down. You should be good at this. Last step is I have to factor by grouping. I can divide these both by 1 and take out an x. 1 divided by 1 is 1 with an x. 3 divided by 1 is 3. These guys here, I can divide them both by 3. That leaves me with a 1x and a plus 3. If your parentheses match, it means you did it correctly. So my final answer is 1x plus 3. So I got that from these guys. And then the numbers from the front was another 1x plus 3. So that's what we learned in Unit 9. The only difference in Unit 10 is we now need to set it equal to 0, because right here it says equals 0. So I take both parentheses and I set it equal to 0. The way that we solve for x is we start by moving the number that was by itself. That's the subtracting 3. That leaves you with 1x equals negative 3. To get x by itself, we divide by 1. Negative 3 divided by 1 is the number x equals negative 3. We do the same thing here. To get x by itself, you move the constant. You divide. This says x equals negative 3. If it's the same number, it means that in this graph, negative 3 is the only solution. So your graph would look like this. Okay? In all of the other ones, you'd have 2 different answers. But in this first example, both of them were the same, which is fine. So when you're ready, I need for you to try that for number 8, number 9, and I'll do 10 with you. So try 8 and 9. So draw an x, find your factors. Once you have your 2 factors, you set them equal to 0, and your final answer is x equals something and x equals something. And number 10, so go ahead, try 8 and 9. Okay, so number 10. So in number 10, what we have here is we need to do something called, it's called the difference of 2 squares. So this one is special because both of these numbers are perfect squares. So what number times itself is the number 4? 2 times 2 with an x. What number times itself is a 1? 1 times 1. How do we make a negative? One had to have a plus sign and one had to have a minus sign. So now that leaves me with 2x plus 1 equals 0 and 2x minus 1 equals 0. So these are my 2 equations. So I factored, this was a special case, it's called the difference of 2 perfect squares. 2 times 2 is 4x squared. 1 times negative 1 is negative 1. If you multiplied those out, the middle term cancels, which is why it's a special case. So now, because it's set equal to 0, the Unit 9 part of this is that we have our factors. Now we need to solve them. To get x by itself, I'm going to subtract 1 from both sides. Then I'm going to divide by 2 and divide by 2. So the answer for this is x equals a negative 1/2. In this next example, to get x by itself, I have to move the 1. Now to get x by itself, I divide by 2. 1 divided by 2 is 1/2. So if you were to graph this, one of your solutions is negative 1/2. The other solution is positive 1/2. You connect your dots, and that's what the answer would be. So in this last example, the final answer is that x is 1/2, that's one solution, negative 1/2, and positive 1/2. Okay, so that's a lot. But the reason why we factored is to be able to figure out the 2 quadratic solutions, or the 1, for some cases, 1 quadratic solution for my parabola.